So 8.1, we're going to be graphing rational functions. A rational function is just a function expressed as a fraction. Okay, so the parent function is f of x equals 1 over x, which if you look at this graph down here, that is the graph of that parent function. So this is what most rational functions look like. Not all of them do though, okay, but it's going to look something like this. Okay, it looks like you have two graphs on one. So there's going to be times where you have two separate sections. There's going to be times where you have three sections. Okay, so what splits it is what we call the asymptotes. Okay, so in Algebra 1, you should have learned about exponential growth and decay, and those have asymptotes. Okay, because we're not at the calculus level, we just tell y'all that's what the graph approaches but never actually crosses, and that's not really the mathematical definition. Okay, it has to deal with the limits, but that's again calculus, so we're just going to think of it as what you get really close to for your graph, but you don't necessarily cross it for vertical asymptotes. Okay, so what you're going to do is check to see if you need to factor it. Okay, that's always your first step. If you have an x squared or x cubed, you need to check to factor. Not every single one will need it, but you check for it. Then what you're going to do is you're going to find a restriction on the domain. So because these are fractions, what happens if I take 5 and divide it by 0? I would get undefined because you can't divide by 0, right? So you have to find that denominator, set it not equal to 0. You're basically setting it equal to 0. But you just have, it cannot equal 0 because you can't divide by it. Okay, so that's your restriction on your domain. What value makes that denominator 0, and that's what it can't be. Because it can't be that, that leads you to your vertical asymptote. So we'll throw this all together when we do an example, just telling you what this is. So that's where you get your vertical asymptote from. Okay. Then we're going to have horizontal asymptotes. This is something where you've got 3 rules that you're going to have to memorize. Okay. So going back to our restriction, if I use this parent function, okay, f of x equals 1 over x. My domain restriction in order to find that, it says set your denominator, which is x, and say that it cannot equal 0. Some of them are going to be x plus 3. Some of them would be x squared minus something. Okay? Whatever that denominator is, you set that and say it cannot equal 0. Okay? That will lead me to my vertical asymptote. So all you're doing is saying my asymptote is x equals 0. So they're the same answer. Just your restriction has a not equal to, your vertical asymptote is equal to. Okay? So if you get this correct, you get this correct. If you get this wrong, you're getting this wrong. Okay? So for my vertical asymptote, remember vertical is up and down. Look at this graph. Notice that it gets really close to the y-axis, but never crosses it. That is that x equals 0. Okay? And we're going to have a dashed line there. Okay? That's very easy to find. Your horizontal asymptote comes from these rules, and what you're looking at is the degree of the numerator and the degree of your denominator. Okay, well, what even am I talking about? Okay, remember that those are exponents, right? If I have a polynomial, your degree of the polynomial is your highest exponent. So I'm going to be looking at the exponents of my numerator and denominator. So my first rule says if the degree of your numerator is less than the degree of your denominator, then your horizontal asymptote is y equals 0. Okay? So an example of something like that would be if I had f of x equals x plus 3 over x squared minus 7. Okay? If the degree is the exponent, then the degree of my numerator is just a 1, right? Because it's x to the first. The degree of my denominator, I'm looking at the exponent, is 2. Since the degree of my numerator is less than the denominator, then my horizontal asymptote would be y equals 0. Okay, so that's rule number 1. Rule number 2 says, what if the degrees are equal? So what if I have f of x equals 3x squared plus 1 over 5x squared minus 2x plus 3? What if I have that? Okay, we'll see how it's x squared on the top and x squared in the bottom. That means the degrees are equal. Okay, so what I do for my horizontal asymptote is I take the leading coefficients and I set up that ratio. So my leading coefficient is 3, this leading coefficient is 5. My horizontal asymptote is y equals 3 over 5. Do we understand how I did that? Okay. Now, if the numerator is greater than the denominator, then I just have no horizontal asymptote. So that would be if I had f of x equals x cubed plus 5 over x minus 7. My degree of my numerator would be 3. My degree of my denominator would be 1. So I would have no horizontal asymptote. Okay, so you're going to have to memorize those rules. So if I'm looking at my parent function, for my horizontal asymptote, my degree of my numerator, if it's just a constant, there's no x, then that degree is 0. Then I've got the degree of my denominator, it's just x, so that degree is 1. Numerator is less than denominator, right? 0 is less than 1. So my horizontal asymptote would be y equals 0. So here in this graph, it gets close to the x-axis but never crosses it. That's going to be your horizontal asymptote right there. Now, there's going to be times where it can cross your horizontal asymptote. It will never cross your vertical asymptote. Okay, the reason being is, where are those asymptotes coming from? Your vertical asymptote is coming from your denominator restriction. That's a very clear, there's no leeway with that. But your horizontal asymptote is just coming from the exponents of your numerator and denominator. That doesn't really, that's not mathematically illegal to cross that, okay? So, these first 3 examples, we're not looking at a graph, we're just analyzing algebraically. So, if I have f of x equals 1 over x to the third, I'm going to take, x minus 3, I'm going to take x minus 3, it cannot equal 0. Okay, well, I need x. I need to know what x cannot equal. So I would just add my 3. So that domain restriction would say x cannot equal 3. Okay. Well, that restriction tells me what my vertical asymptote is. So that tells me x equals 3 is where I have my asymptote. We good with that? Alright, my horizontal asymptote, what is my degree of my numerator? 0. Degree of my denominator? 1. Top is less than bottom, right? So my horizontal asymptote is y equals 0. Okay, questions? Why do I do what? This? Oh, just because it's the notes and I'm showing it. X cannot equal 3. So that's my restriction. That's your restriction on the domain.
Oh, so you don't have to write like this.
No. Because really what that's telling you is it's all real numbers except X cannot equal 3. We just cut down the word restriction. Okay, so here I've got x minus 2 and x squared minus 16. I have an x squared now. I need to factor this. Okay? What do you recognize about x squared minus 16? What is that?
It's difference of 2 squares.
Difference of 2 squares. So I need to factor the difference of 2 squares. So when we do that, my formula tells me one's a plus and one's a minus. If you don't remember, our formula was a squared minus b squared, and that would give you a plus b times a minus b. Okay, well, where did the a and the b come from? One, they have to be perfect squares, then you just square root it. Okay, so if I have x squared minus 16, it's going to be x and x. Square root of 16 is 4. You have to factor it. Okay? So now I have 2 parts to my denominator, so that means I'm going to have 2 restrictions on my domain. X plus 4 cannot equal 0, and x minus 4 cannot equal 0. Okay, so if I have x plus 4 equals 0, I would subtract my 4, and it would tell me x cannot equal negative 4. And then x minus 4 cannot equal 0. I would add my 4, and it would give me x cannot equal positive 4. You follow me for that? Okay, so then your vertical asymptote is connected to that. What are my asymptotes for that? X equals 4 and x equals negative 4. The same exact thing, it's just equal to now. Okay, then my horizontal asymptote, what's the degree of my numerator? 1. Degree of my denominator? 1 is less than 2, so my horizontal asymptote is y equals 0. It will always be y equals. Vertical will always be x equals. Okay?
How do you have the factor thing again after a squared minus
So this is my difference of 2 squares formula. If I have a perfect square here, it's just x squared minus a perfect square. Then all you're doing is breaking that into x and x. One's always a plus, one's always a minus. And then the square root of 16 is 4 and 4. Now I could have a number and it still be the difference of 2 squares as long as the coefficient of x squared is a perfect square. Okay, now here I have x cubed plus 5, x squared minus 3x minus 28. So I need to look, can I factor x cubed plus 5? 5 is not a perfect cube. We have done sum and difference of 2 cubes, but 5 is not a perfect cube, so we don't do that. Okay. X squared minus 3x minus 28, I can factor that. Okay. So remember that when you factor a trinomial, you take factors of your last term to give you your middle. Okay, well that 28 is negative. So that means they're going to be opposite signs. Hopefully y'all remember that. Okay, what factors of 28 are going to give me a 3? 7 and 4. Okay, remember when they're opposite signs, the larger factor takes the sign of the middle. That middle sign is negative, so my 7 is negative, my 4 is positive. Okay, so x plus 4 cannot equal 0, and x minus 7 cannot equal 0. So my restriction on the domain tells me x cannot equal negative 4, and x cannot equal 7. So my vertical asymptotes are x equals -4 and x equals 7. And then my horizontal asymptote, the degree of my numerator is what? 3, and the degree of my denominator. So now my top is greater than the bottom. So it would be none. Okay? Are we good figuring these out? Okay. So when we go to graphing, you're doing all of that, and then when you're done with that, you just type it in your calculator and get the tables and graph. Okay? So that's why I say this is not a hard lesson. Alright, so I'm going to start, we have a little bit of time before lunch. I'm going to start with my restriction. My denominator is just x, so x cannot equal 0. So then my vertical asymptote is x equals 0. So for my horizontal asymptote, the degree of my numerator is 1. The degree of my denominator is also 1. I have an x and I have an x. Okay? So I'm going to take the coefficient 2 over the coefficient 1. 2 over 1 is 2. So y equals 2 is my horizontal asymptote. Okay? That came from my leading coefficients. Y'all good with that? Y'all go to lunch. So once you get these, before I go and get the table from the calculator, I draw my 2 dashed lines that I'm going to have so I can kind of see where my graph is splitting. So this will be my vertical asymptote. And then y equals 2 will be my horizontal asymptote. And then once you do that, you just need to go to your graph. I would say don't go in your documents, because when people go to the documents, they've got about 5 tabs up here. So go to your scratch pad and then hit that calculator button, and that will give you your graph. Okay, so then control divide will give you your fraction template. So 2x plus 5 over x is my function. So whatever you start with is what you graph. And it should look something like that. Okay, and then I'm going to get my table, control T. Now, my rule of thumb is typically just go from -10 to 10. You're not having to put all of those points, because you're going to see that a lot of the decimals look very similar. They would round to about the same thing. So I'm going to be skipping around to whatever points are going to help me make my curve. Okay, sometimes that's more than enough points. Sometimes it's only a few points. So you'll graph this function, your original function, 2x plus 5 over x. Yeah, we're going to have decimals for our y's. Do we all have this on our calculator before I keep going?
1 second.
Okay.
Sorry.
It's
What
okay.
is hashtag you?
That's undefined.
Oh, I can see it. Hashtag. What is it, a number? What does that mean? That's a silly question.
Okay, so we're going to go from -10 to 1.5. You can just, it's just letting you know it's undefined, so you can think of it as a hashtag.
So there's a hashtag.
Yeah, so I'm gonna get there. Just hold on. Okay, so we're gonna start at negative 10. You could even start at negative 11 if you wanted to, but negative 11 and negative 10, those y's, all of these three y's are pretty much the same. So I just kind of skip around until I see, not necessarily just an easy number, because not every graph is gonna give you just easy numbers, but some that are gonna make a difference on where you're graphing. So I'm gonna do negative 5, 1. If you wanted to do negative 4.75, you could. Negative 2, negative 0.5. Negative 1, negative 3. Now, for 0, we've got the hashtag undefined. Okay, that's what that's standing for. Well, what do you know about x equals 0? That's your vertical asymptote. That's why it's undefined, because it would make your denominator 0, and you can't have that. So that's why you have an undefined there. We're still going to put that in our table, and then we're going to keep going. So that means that it's going to break right there, and then we've got, if you run out of space, just continue the table, just build another table if you're out of space. 1, 7, 2, 4.5. I'll probably do, I'm going to continue my table, 5, 3. And 10, 2.5. So some graphs, you're going to have a lot of points on the table, some you're not. Okay, just enough to give you the curve. Now you've got your calculator, so you should not have a graph that does not match your calculator. I get that all the time. Okay, so make sure whatever you graph from these points makes sense according to this graph on your calculator. And then it just gets close, but never actually crosses that asymptote. So there's my first half. Then once you reach your undefined point, then you're going to start with your second part of your graph. And that's it. All right, next problem. 2x over x squared minus 9. Okay, I'm going to do, before I can do the restriction on the domain, what do I have to do? I have to factor it. So x squared minus 9 factors into what? It doesn't matter if the plus or the minus comes first, as long as they're one and the other. So then I need to have my domain restriction. So if you're doing x plus 3 cannot equal 0 and x minus 3 cannot equal 0, what are my two restrictions? X cannot equal negative 3 and x cannot equal 3. So then my vertical asymptotes are what? X equals negative 3 and x equals 3. then for my horizontal asymptote, the degree of my numerator is what? 1. And the degree of my denominator is 2. Top is less than bottom, so what's my horizontal asymptote? Y equals 0. So I'm going to graph my dashed lines. And then once you do that, you can just dock a B to get rid of the graph and go back to your graph in the table, in the calculator. So I'm not going to put the factored form. I'm always going to do my original. So 2x over x squared minus 9. So here, notice that I had 2 vertical asymptotes, right? So it kind of cuts this graph into 3 sections. Notice that this middle will be crossing my x-axis, which is my horizontal asymptote. That's okay to cross your horizontal asymptote. You will not cross your vertical, though. Okay? So I'm still going to go all the way to -10 just to see what my points look like. Or -11. Okay, I'm going to do -9, -0.25. I'll skip to -5, -0.6, -4, -1.1. And then my -3 is undefined. Then I've got -2, 0.8, -1, 0.25, 0, 0, 1, -0.25, and 2, -0.8. Then 3 is undefined. So if you get specific vertical asymptotes and that's not undefined in your table, then you need to look back at how you factored. Okay, so seeing that it's undefined for these x values is kind of like a self-check that you can do to make sure you got those right. So for 1.1, I can skip to 7.35. And then 9.25. You could always change your table settings to do like 8.5 and stuff like that. I don't. You have what your graph should look like, so you should be able to see what happens. Okay? So that is what it looks like when you plot your points in the middle. So as long as you're using your calculator as your guide, then you know that it goes up and then starts to curve and flatten out and then goes straight down. Kind of like a cubic function.
If it wasn't
So that's what I was saying. So your horizontal asymptote, you can cross because you only get that asymptote by looking at your degrees of your numerator and denominator. So nothing that's like mathematically illegal. But you will never cross a vertical asymptote because that's what makes your denominator 0. So that's why it's undefined there.
Can you give me a second?
Question? Y'all good graphing that? Do we have questions? Okay, so for the next example, I need a factor, x squared plus 6x plus 5 and x squared minus 4. So my numerator, I want factors of 5 that will give me 6. Well, I only have one pair of factors for 5, which is 5 and 1. So x plus 1 and x plus 5. And then x squared minus 4 will factor into what? X plus 2 and x minus 2. Now there are times where you could factor and factors cancel. That would create a removable discontinuity. I took that out of your notes. But that is such a thing. Okay? So we're not going to deal with that right now. But if you have if you have to take a college algebra course, you'll do probably removable discontinuities. Okay? So the domain restrictions are going to be what? So it's always your denominator. So x cannot equal negative 2 and x cannot equal 2. So my vertical asymptotes, x equals negative 2 and x equals 2. My horizontal asymptotes, what do you notice about the degrees of the numerator and denominator? They're the same. They're equal. So I need to do a ratio of my leading coefficients. So my horizontal asymptote is 1 over 1, which is just y equals 1. So when I go and graph it and go to my table, negative 10 can round to 0.5. I can do negative 8, 0.35. negative 5, 0, negative 4, negative 0.25, negative 3, negative 0.8, negative 2 is undefined, as it should be. Then negative 1, 0, 0, negative 1.25, 1, negative 4, and then 2 is undefined. Then I've got 3, 6.4, 4, 3.75, and we'll say 8 can round to 2. And I'm going to just use those. Okay, do we have any questions on that? Okay, last one. We've got 4x squared plus 4x minus 24 and x squared minus 5x. So, the examples before, we didn't have coefficients in front of x squared, but now we've got a 4. Remember that when you factor, you should always be checking for a GCF. So, here, I've got 4, 4, and 24. What could my GCF be? And that would leave me with what trinomial? Minus 6. All over. Now I have an x squared minus 5x. Can I do a GCF with that? Yes. What would it be? X. If I take out an x, that leaves me with x minus 5. Okay? So now I need to factor x squared plus x minus 6. So what does that factor into? I need factors of 6, x plus 3, x minus 2. Alright, because it's a minus 6, so that's going to be different signs. Larger factor takes the sign of the middle. So then the restriction on my domain, I've got two parts to my denominator. I've got an x and an x minus 5. So it's going to be x cannot equal 0 and x cannot equal what value? 5. If you need to do the x minus 5 cannot equal 0, to see that you add 5 to get that, then you can. So then my vertical asymptote tells me they're going to be x equals 0 and x equals 5. My horizontal asymptote is going to be what? Y equals 4 because they're both x squared. So my leading coefficient is 4 over 1, which is just 4. We good with that? I'm going to clear my calculator and type my original Does anybody have something other than this? For those of you who are doing it in your calculator, do y'all have this? So I'm going to have negative 10, 2.2, negative 6, 1.5, negative 5, 1.1, negative 3, 0, negative 2, negative 1.1, negative 1, negative 4, and then 0 gives me undefined. Then I have 1, 4, 2, 0, 3, negative 4, 4, negative 14, and 5 is undefined. Now, I need to continue my table. 624 isn't going to fit, but you can do it so you know how far down it should look. Then 8, 11. You can do 9, 9.3, and 10, 8.3. It just doesn't show it on here because your y's only go from a negative 6 and a positive 6. If I had a further x-axis, I would see that would start leveling out. But all we have right now is this. Okay? Y'all good with that? So for your worksheet, number 15, y'all's last problem, you don't have to do the table or the graph because the table is weird, the graph is weird. So you can answer the domain restriction, vertical asymptote. You can do that. You just don't have to graph it, okay? That's the only one. Everything else should be fine.